Calculus and Vectors Performance Test. Here's the first question. So the first question was to use a matrix to solve or balance the following differential equation. So here we have it, and the way we can do that is by assigning the coefficients, which we'll have in the end as x1, x2, x3, and x4. And then if we look at iron, for example, we know that there's 2 iron over here in x1, so we can do 2x1 equals x3. If this is x2, we can look at oxygen as well. So we have 3 oxygen as x1, plus 1 here as x2, and that has to equal to the 2 in x4. And then carbon x2 equals x4 because we have 1 here and 1 here. We can use these to help us in the end. And also we can set x4 as the parameter t, which will help us in the end. And here's the matrix that we're going to have to solve, in which we'll have 1, 1, 1, 0, 0 around here, and then whatever numbers we'll have here. So I put this into a matrix right here. To start off, I did 2 row 1 minus row 2, and at the same time I did row 3 minus row 2 to get some zeros in here and get a 1 up here. From there, I did row 2 plus row 3 to get another 0. Continuing from there, I did row 1 plus row 2, getting me some more zeros, getting another 1, continuing like that. From there, I did row 3 plus 3 row 1 to get a 0 down here. And from there, I did 3 row 1 minus row 3 to get a 0 up here. And then the last thing, if I looked at it, I just needed a 1 here and a 1 here. And the way I could do that, since these were both zeros, I could just divide by 3 here and divide by negative 6 here. And so if we do that, we end up with this final matrix, which is we have the 1, 1, and 1 with the zeros in the right spot, and these 3 numbers right here. Now, when reading this matrix, we can see that 1x1, because originally that's what each of the rows are, x1, x2, x3, x4, you can say that. Originally, what we could say is 1x1, because we have 1 here, plus negative 1 over 3x4 equals 0. Same thing over here, 1x2 plus negative 1x4 equals 0, and 1x3 plus negative 2 over 3x4 equals 0. And so these we can summarize as follows. So we have x1 minus 1 over 3x4 equals 0, which basically means x1 equals 1 over 3x4. Now 1x2, we can summarize that as x2 minus x4, which equals 0, so x2 equals x4, we bring that over to the other side. And then this one we can summarize as x3 minus 2 over 3x4 equals 0, and we bring the negative 2 over 3x4 over the other side, it becomes x3 equals 2 over 3x4. And so now let's just set the parameter t equal to 1, which will take the place of x4. And so if we were to do that, we would have x1, x2, x3, x4 as coefficients, in which x4 is the 1. And if x4 is 1, we can plug that into here. So if this is 1, x1 would have to be 1 over 3. This would have to be 1, and this would have to be 2 over 3. And so we can put that into 1 over 3, 1, 2 over 3, and 1. But we do not want fractions as the coefficients in the balanced chemical formula. So we know if we just multiply them all by 3, we'll get rid of these fractions. And so when we do that, we get 1 Fe2 of 3 plus 3, because we multiply that by 1, 3CO, which becomes 2 iron plus 3 carbon dioxide. Now we can move on to question 2 of part 1 of the calculus performance test, performance test. So in this one, we had to balance another chemical equation, which we had C7H8 plus HNO3, which becomes C7H5O6N3 and H2O. And so once again, we keep coefficients as x1, x2, x3, and x4, which we can solve using a matrix. And so when we plug in the values of the molecules of each, we create this matrix right here, which we can manipulate to figure out the overall values of x1, x2, x3, x4. And before we start off, we just want to remember that x4 we can create that as a parameter t. Now we can move on. The first thing I saw that would help was dividing by 7, dividing by 3 to get smaller numbers, and also to get a 1 here, I guess. And so I did that, and we can move on to here now. From here, I decided to do R2 minus 8 row 1 and R3 minus R4 to get some zeros into my matrix, because once I have my zeros, I can just divide in the end. Then I did row 1 minus row 3 again to get another 0, I believe. Yeah, another 0. And then I did row 3 divided by negative 1 to make this a positive 1. And row 4 minus row 2 to get a 0 right here. And so we continue down here. We did row 2 minus 3 row 3. And so that eliminated everything mostly except for this negative 5. And lastly, I noticed that this negative 5, there's a 1 here, so you can just do negative 5 plus 5. And so ideally, you want to do row 3 times 5. So you do row 4 plus 5 row 3 to get 0, 0, 0, 0 in the bottom row. And then this became a solved matrix. And so the values I got over here were negative 1 over 3, negative 1, negative 1 over 3, and 0. And so ideally when you look at that, that becomes x1 equals 1 over 3 x4, x2 becomes x4, or x2 equals x4, x3 equals 1 over 3 x4, and x4 equals 0 x4, just because if you were to read this, it would mean 0 x4 is equal to 0. And so once I did this, I decided to get the parameter t a value of 1 to get the yield, which represents x4 as well. And so if you keep the 1 for the x4, we can use these to figure out the values of x1, x2, and x3. So in that case, x3 and x1 became the value of 1/3, and x2 became the value of x4, which is 1 as well. And so we got this formula right here, or equation right here. But then if you notice, the coefficients do have fractions, and so we can just multiply it by 3 to get rid of the denominators and get whole numbers. And so doing that, you got 1 C7H8 plus 3 HNO3 becomes the C7H5O6N3 plus 3 H2O, and that is the solved matrix. Here's the second question of the performance test interview. In this question, we had a scenario which could be solved using optimization. And so the scenario basically involved two people walking into a taco cart, and you having to find the fastest way to get there to beat both of them. We had one person who went directly across the sand. We had one person who went halfway across sand and then halfway, well not halfway, but he took some X proportion on the sand and then some Y on the sidewalk. And they got there, and what you want to do is to optimize the situation, so you want to walk across the sand in the right amount so that you can walk across the sidewalk in a small amount and get perfect time. And in order to do that, we can create this equation in which the time can be represented as 325.6 squared plus x squared, all square rooted, because that's this right here. Because we can use Pythagorean theorem to figure out that hypotenuse. And that divided by 2, because that's going to be the overall time, because the speed is 2 feet per second in that way. And we know that because time is equal to distance over velocity or speed. And so we continue with that. So this is going to be the overall time on the sand, and this is going to be the time on the sidewalk, because the sidewalk's overall length is 562.6 feet, and we can say that there's going to be some x proportion which you're not going to have to walk, and so overall distance on the sidewalk is going to be 562.6 minus x feet. And so that's all going to be divided by 5, because you can go 5 feet per second on the sidewalk. And again, so this will give us time of this, and this will give us the time of this, and when we add both the times, this will be your overall time. And so now we can continue by trying to find the derivative of this equation. And so the first thing I did is to use power rule to bring out the 1/2 that would be in front of the square root. So it becomes a negative 1/2. This 1/2 comes up here. We know this is a fraction, so we can also say it's basically multiplied by 1/2. And it's multiplied by 2x because that's inside the bracket, or inside the square root. And then on this side, we know it's going to be plus 1/2 times negative 1 when we find the derivative of this, because this instead of 1/2, this becomes negative 1. We continue on doing that. We know that there's a 4 out here, because when you bring this down to this negative 1/2, you basically say it's being square rooted as a denominator. You know that there's going to be a 4 in front of it from these being multiplied becoming a quarter. And so the 4 and 2 can cancel it from above, and so this becomes 1x and this becomes 2. And on this side is again minus 1 over 5, because there's a negative 1 being multiplied. Now when we're solving an optimization problem, we want to set the derivative to equal 0 to figure out the value of x. And so I continued by doing that, so I set this as 0 and kept solving. So I moved the negative 1/2 over, or 1/5 over to the left side, and then cross multiply to get 5x equals 2 times the square root of this expression right here. And then you know that this is a square root, so you can square this side to get rid of it. And so 5x squared becomes 25x squared, and now we've eliminated that square root here, and we can distribute the 4 outside of it into it. And so we get 424,061.44 plus 4x squared. Now we can move the 4x squared over here to make that 21x squared equals this number, and then square root both the sides, because we have a square root, we have this number squared, and so it becomes x as 142.1 or negative 142.1 because it's in the square root. No, sorry, because we're squaring that number. But obviously it makes more sense to have the positive number because we're not walking backwards. And now continuing on from that x, what the x actually represents is just this portion right here. So now we need to actually figure out the length of this and the length of this. And so we can start by using the easy one. And so we know 562.6 minus x equals the distance on the sidewalk, as we saw right here. And so I continued by using the x value we found, solved that to be 420.5 feet. And the second part that you can walk across the sand is going to be the hypotenuse of this smaller triangle with x and 325.6 feet. And so I used Pythagorean theorem right here to get the value of the hypotenuse as 384.6 feet in the sand. And we know that this answer is right because when you check the overall time of each person, so Ben, I believe, was walking straight across and then all the way over, it was 325 seconds. Mr. Mitchell was walking just across to the sand, was 275 seconds. And then if you were to figure out the overall time after solving this equation, it becomes 261 seconds. So we do know that it's been optimized and that this is the right way to go.
So now moving on to the second part of the second question of the performance task. The question asked to figure out at what point on the sidewalk could you place the cart so that all of the three people land at the exact same time. So here's what I have done. Originally, I came up with the idea that you're gonna have to have some spot X right up here that that two people can just walk across because Mr. Mitchell only uses the sand, and you try and find the optimum point. So or you go through the sand as well. So you'd both be using the sand, and then this guy would have to go straight up and across. And at some point, you'd find the fastest route. Now, what I realized after that is if I do something like this, where the cart is placed exactly above the starting point, then they all have to reach at the same time because they only have one actual route to go. And so if you look at the first guy who normally goes across straight perpendicularly and then X amount on the sidewalk, well, if he goes 325.6 feet straight up, he doesn't have to go anywhere in X because the cart's already there. Mr. Mitchell finds the fast route on the sand, and for him it's also just to go straight up. He has no other way to go. So for him it'd be the same speed as this guy, and it'd be the same time because they're still traveling 326.5 feet as well. 325.6 feet. And lastly, for you, you'd also have to use this route, and so for you the time would have to be the same because there's no other way to get there. For example, you can't go this way and then come back, or go somewhere over here and come back, because this is the only spot that would make sense to go. And then I tried to show it with math, and so if you look at the guy who'd normally have to go straight up and over, you could say that he has to go 325.6 feet, divided by the 2 feet per second to get his time. And so that's basically saying he has to go up this much, and that would take a certain amount of time, plus X over 5 because he's going X on the sidewalk, and divide that by his 5 feet per second. And so in that case, we're saying X is 0 because he doesn't have to travel anywhere in X. And so if you set X as 0, it becomes 325.6 divided by 2. As far as Mr. Mitchell goes, he just takes the hypotenuse. And so if you were to figure out the hypotenuse of this, it would basically be 325.6 squared plus X squared, all square rooted. And so all divided by 2 after, because it's only on the sand, which is 2 feet per second. And so if you were to do that and set X equal to 0, then since you're not going to go on the sidewalk, then you get once again 325.6 over 2, because originally you have this, in which X becomes 0, which cancels out the X, which becomes square root 325.6 squared, which basically eliminates the square and the square root because it's basically the same thing. And well, it's not the same thing, but they eliminate each other because they're opposites. And again, that divided by 2, which gives you the same time overall as the original way, which would be going straight across an X amount over. And so I found that the place to put the cart to get all of them to get that at the same time would have to be straight up, because that's the fastest way for all of them to go. Now for the final part of the performance task, the reflection. Now the first part of the reflection just talks about work ethic and your work habit and learning skills throughout the semester. And so I believe that throughout the semester my learning habits and work habits have been up to par. And by that I mean through each unit, during each topic that was discussed, I was able to keep up with the homework and follow through on my part in understanding the topic so that I could keep up with the material. As we moved into the course and got to the point where we started to graph, I didn't have as much interest as I did during related rates optimization or matrices and stuff like that. And so during that time, my interest did go a little down, and because of that, I did slack a bit when it came to homework. Apart from that, I believe that my work habits and work ethic was at par because I really enjoyed the course as a whole and really enjoyed doing the homework, and it really made me want to do it. The next part of reflection talks about how I use my knowledge in the questions in the performance task itself. And so for question 1, I used my knowledge of matrices that was taught earlier this year to solve and balance the chemical equation. And I believe that being able to actually solve the equation shows that I have a decent understanding of the topic that was taught. And the second question actually was an optimization question, in which I used things such as the power rule, the chain rule, stuff like that, derivatives and calculus to really help me get the answer. And not only that, I used the idea of optimizing situations for the best possible answer, and that really demonstrated that I was able to grasp that concept when it was taught and then later on apply it in my performance task. The next part of the reflection is to discuss my favorite topic this whole semester. And I don't necessarily have one favorite topic. I really enjoyed matrices when that was first introduced in the first couple lessons when we were doing vectors, just because it was a whole new concept that I've never actually known about, and so I really enjoyed the whole idea of it and really found it really interesting. Another really cool thing for me was when we did related rates and optimization, just because that topic really brought into those real life applications that you normally never get to discuss in other topics or other math courses or even other subject areas in high school. And so those two would have to be my favorite topics this whole semester. And lastly, as far as my mark goes, I believe that around 93-ish would be where I stand, just because I put in a ton of effort, did all of my homework, and they just accurately represent my mark, because as far as tests went, I didn't make mistakes which showed that I didn't understand the concept. It was mostly just me making small silly mistakes, which could happen anyways, but as far as it goes, me understanding the topic, I believe I definitely understood what was being taught and was able to apply it later on, to the point where now I can do it without having to refer back to anything or really check on things being taught or review any lessons, because I've done enough homework to actually understand the topics and really know what's happening by myself.